Lecture 6, Buoyancy, Floating, Flotation and Stability. The first starts from the Archimedes principle. They said that the buoyancy force on a solid is equal to the weight of liquid it has displaced and is x to the centroid of the displaced volume. Okay, you can see that is the centroid of the displaced volume, and this buoyancy force in the green color is the displaced volume. In case of the floating and in case of submerged, it's the same. C is the centroid of displaced volume, FB the buoyancy force. If we write the equilibrium for the submerged body in this figure, so we have F1, F2, F3, F4, and weight and FB. So we can write equilibrium equation for this condition. Say summation of along an x direction. So F3 subtract F4. This means F3 and equal to F4. And for vertical direction, if force y equal to 0, so F2 subtract F1 subtract F3 equal to FB. And prove that FB is equal to the direct F2 subtract F1, or is a net effective net effect of pressure force. Okay. And for buoyancy force, this is the equation for buoyancy force equal to gamma times the volume, displaced volume. Okay. So SB is a buoyancy force and gamma specific weight, and volume, the volume of displaced water. And buoyancy force acting on the centroid of the volume. So in case of this figure, we have different it's a floating solid, but we have different liquid, rho 1, rho 2, rho 3, and rho 3 is greater than rho 1 and greater than rho 3 is greater than rho 2 and rho 2 is greater than rho 1. So we can have C1 is the center of the total solid, okay, and C2 is the centroid of the displaced volume, okay, and we call the C2 is the centroid of displaced volume, or the center buoyancy. If the gamma is vary with the depth, so as in the both case, FB will be x to the center of gravity C3. So you can see that the C3 is the center of gravity. It's not the same point of displaced volume of fluid, not centroid of displaced volume. The example show the sphere of the 1.5 diameter, weight of 8.5 kilonewton. Find the tension T in the cable. So we can write a fibry diagram of the equilibrium. These three forces FB, U, and T. So in case of sphere, the volume is equal to 4/3 pi power 3. We can convert to diameter equal to pi over 6 d power 3. So make equilibrium for summation of force. Y-axis is 0. So we can write equilibrium equation Point C4 subtract weight, subtract tension, tension is equal to 0. And T is equal to the FB subtract W. FB equal to gamma times volume and weight, given the weight is 1.5 10 power 5. Okay, so we can find the gamma of seawater form is equal to about 10,000. So we can substitute the gamma for seawater, and the area the volume is power 6 d power 3. So the final tension is 9,350 Newton. Okay, for the solution of the cable tension.